All right, so for this one, we've got two things we're doing. We're going to do square root property, which is really, really, really straightforward, really easy. And then the other thing we're going to do is completing the square. And completing the square is one of those things that's kind of, it's optional. You don't have to do it this way. We're just going to show it to you because there's sometimes some people like to do this one once you get the hang of it. Some people don't. It just depends on how you think and what you want to do. So um, it's just, these are some other things you can do in place of factoring, in place of the quadratic formula. So just some other options you can do to help you solve when we're going through some stuff on this thing. So, all right. So when you're doing the square roots, when you're doing square root property, there's a couple of different ones that we'll do. We'll show you both of these and kind of show you how it is kind of working for this part of it. But mostly we're going to do square root property when um, you basically have two terms. And then we'll actually show you another way we can do this later on where it's not just with two terms. Okay, so for square root property, the very first beginning of it, where we first learn how to use this to make it be the easiest thing we're going to do, is you use the square root property when we're doing a quadratic and the b term is missing, because it makes the work really straightforward, makes it really easy because of how it is you're going to do this thing. Because it's only two simple. It's even easier than Dora. There's only two simple steps and not three simple steps. Dora's always three simple steps. In this case, there's only two we're going to do. Basically, for step one, you get the x squared term by itself. And then step two, you do what it says in the directions there. You square root both sides. Okay. And again, there's another way we can do square root property. I'll show you a little bit later, where there's more than two terms, but this is the basics of it. This is where you would really want to use it to kind of get the most out of it when it comes down to it. All right, so here we go. So we'll give you the first one where it's already set up. And most of this, you're going to go, well, okay, well, that's easy because we're used to doing this. So what if it's x squared equals 49? Well, we'll just square it both sides, right? Okay, and then the one thing we know is from what we were talking about earlier, that if we're doing this one, and they're almost always going to be this case, if it's x squared, we're looking for two terms. Yeah, so we know we're looking for two answers. So we take the square root of 49, should be plus or minus 7. And you got your two answers. All right, now, one thing I know, since we got this test that's coming up tomorrow with Math Excel, if you want to be careful with Math Excel when you're putting in your answers, you might want to put x equals -7, comma, +7. Because I know there's some answers, it will tell you to put a comma between the two answers. So that may be one thing tomorrow when you're doing this test that you might want to go ahead and write both answers separated by a comma, just to be on the safe side. Now, again, that's one of those issues where if you put this answer and they count it wrong, it's not wrong. It's just not in the format they want. So don't worry about redoing that one if you do the test tomorrow. So, if you put this answer and they count it wrong, it's not wrong. It's just not in the format they want. So, we'll be okay there. All right. So for example, 2, almost the same thing, where you got something like this, where you got x squared minus 81 equals 0. Okay. Again, all you got to do is get the x squared by itself. So we'll just add the 81 to both sides. All right. And then we square root it. Okay, and then square root of 81 is 9. Okay, now again, you don't have to do it this way because one thing that you may have noticed on this one, if we were still trying to factor these things, if we back up for just a second, if we were going to factor this thing, about okay, this is the difference of two perfect squares. And then if you were going to factor this, this would be x plus 9 and x minus 9 equals 0. But when you solve those two things, what are we going to get? Plus or minus 9, right? Because if you factor that, if you did the difference of two perfect squares and then set both of those things equal to 0, well, you're right back to the same answers, just a different way of getting there, which is okay. So whether you do the square root property or whether you do, if you notice it's a difference of perfect squares, either way is fine. It doesn't have to be that it's always one certain set way. We're just showing you, all right, here's another option you can do if you want to solve some things. All right, so let's go with 2x squared equals 50. This time we've got the 2 with the x squared. So first step is just go ahead and divide both sides by 2. And then we got x squared equals 25. Then hopefully at that point, we're okay because it should be pretty easy. X would just equal plus or minus 5. All right, again, if you want to be careful with the online homework, do 5 comma negative 5 because sometimes they will tell you, especially if they tell you to put a comma between the answers, could be either one of those two that's there.
Could it also come up negative 5, 5 or?
Yeah, as long as you got the answers, doesn't matter which one goes first. So. All right, now I'll tell you this is a worst case scenario, but this is maybe a worst case scenario. You got 3x squared equals 60. Okay, so again, you're getting the x squared term by itself, so you divide both sides by 3. Get x squared equals 20. Okay, now with this one, 20 is not a perfect square root, correct? So we've got to do some simplifying, right? Got to break it down, got to find your exit buddies, whatever it is you want to do here. If you start breaking down 20, the first thing I'm thinking is it's 4 times 5, right? But then that does get us a perfect square root, right? Because if we do 20 as 4 times 5, square root of 4 is 2. So the 5 is a prime number, so it's stuck. It won't go out. So that would break down as 2 square roots of 5. And because it was x squared, we do need that plus or minus that would be there. Okay. And again, I'm just thinking of that one because, again, if you can think of a perfect square root number you can divide out of that number to rewrite it as, then do that. So 20, now you could break it down and make it 2 times 10, but if you think about 20 as being 4 times 5, again, square root of 4 is a perfect square, so we make that 2, and then we've just got the square root of 5 that we follow.
What is that? So take the plus or minus that one, or would we have to do? Or we have to do 2 square roots of 5 and then 2.
It's probably gonna go 2 square root of 5, then negative 2 square root of 5. Yeah.
Why wouldn't it be I? 2 square roots of 5.
Oh, only if that's a negative number. If they've been negative 20, then it would be the I. Okay. Which is, you're reading my mind because that's where we're going next. Okay, so everybody okay with that one? All right, now, and Emma was kind of reading my mind there because the next one we were going to do. Was x squared plus 9 equals 0. Okay, first thing is we would subtract 9 from both sides to get x squared equals -9. All right, square root both sides. All right, and we know if it was square root of 9, it would be 3, but because it's -9, it's not just 3, it's 3. Ah, there you go. There you go. So, and that's okay because it gives you the imaginary solutions, and it will say most of the time what I've looked through with Math Excel, most of the time if they're looking for an imaginary answer, they will tell you make sure that you use I in your answer. So they kind of give you that heads up of saying, okay, you're probably going to have an imaginary answer on this thing. Make sure we're there. Okay, so everybody okay with that? All right. Again, that's just an easy one to kind of have in your back pocket that if the B term is missing, then basically you can just, if you've got x squared and a number, you can separate those two things out, square root both sides, and then you got your answer.
So could you also do -3i, 3i?
Yes, you could also do, you could do -3i, 3i. Be okay. Okay. All right, second thing we're going to do is we're going to do completing the square. And then we're going to show you how they will kind of walk that into square root property. So we'll kind of do a little combo of both of these things here. But this is kind of what we're doing. All right, and this is one of those things that if you do this, this is great. If you don't do this and you just do quadratic formula, that's fine too. So it's not one of those things you have to do it. We just want to show it to you so that sometimes there may be something where you might want to do this. All right, and there's basically two different types of completing the squares. The one we're going to do here is we're going to complete the square, but you're going to just find the C term. Okay, so if they ask you to find the missing term for this thing, then basically here's all you're going to do. Again, it's not too complicated for this one. It's basically 2 steps here. Step 1 is you're going to divide the B term by 2. Divide. Try it again. How about we divide? There we go. And then after you divide the B term by 2, you're going to square the B divided by 2. So basically, you're going to take that number you've got of B over 2 and you're going to square it. So this is B over 2 squared. Okay, so in this case, again, what we're going to do is they're going to ask you to find the number to complete the square. You're not actually going to do like all the steps to it. We'll show you that part here in a minute. But basically, we're just going to find the missing number that we're doing for this thing. And it should be one of those examples where they're going to give you something like this, probably, where they give you like a box almost. And you're just going to find the number that would go in the box, or they're going to give you a blank, or they're going to give you something here where you're just finding out what that C term is. All right, B term is 24, so it's just 24 divided by 2, which is 12. And then your second step is you take that answer and you square it. Okay, so they ask you to find the number that will complete the square. There you go, just 144. Okay, and you may be saying, well, what does that do when we get that number of 144? All right, so here's what they're kind of leaning you towards. Here's where they're going with the next thing. That if you were, and this is just like a side note here. So here's kind of where we're going to on this part. That if you did this thing and you found this completing the square thing that was here, you have that. When you take this number and plug it in back here, here's what they're trying to get you to see. What are the factors of 144 that would equal 24? Now I'll give you a hint. Answer's right here. It's this b divided by 2 term. Okay, big 12 and 12. 12 times 12 is 144. If you add 12 and 12, you get 24. So this thing would be m plus 12 and m plus 12, which means this would really be m plus 12 squared. And that's why they call it completing the square, that if you put the right number in here, you can write it as an expression squared. Okay. And again, finding this number is really easy. If all they give you is these two, you take the b term, you divide it by 2, and then you square it, you got your number. Even if it's a negative, that had been a negative 12. What happens when you square a negative number? So it makes it positive, right? So it doesn't matter what the number is, whether it's positive or negative, because you're going to square it, it's always going to come out to be a positive number. So that part really won't matter. The only thing that would be different is that if you were doing a negative number, just show you real quick here. If that had been, let's go with x squared minus 18x. And then they give you the box there. Oops, kind of crooked. Okay, it's negative 18 divided by 2 squared, which is negative 9 divided by 2 squared, which would be 81. Okay, so they ask you to find the missing term. Again, it's always that easy. Just take the number, divide it by 2, and then you square it. Do it. Go back to it. Okay, so again, it doesn't matter if the number is positive or negative, because you're going to square it. The answer will always be a positive number that's there. As long as we're talking real numbers. When you get imaginary, it's a different story. But for these, everything should be real numbers as we're going through this. Okay, now, and kind of that side note on this one again, here, what they're trying to get you to think about in this case is this is basically like a halfway step. That if you kind of went side note on this one, and they ask you to factor, if you plugged in that b value that was here, what they always try to get you to see is that it's always this number, the b divided by 2, it's going to be that number twice. And again, technically that's x minus 9 squared, so that's kind of where they're getting you to go for this one. Okay, so in some of the cases, at times we didn't have enough time to get through this and this one. We got enough time to kind of show you today where we kind of make this thing work out. But that's kind of when they talk about completing the square, that's what they're trying to get you to do, is to find this number that if you put it back in here, then you've got this squared number that you will have.
What would be the right answer? Would you type 81 or would you type 900?
Now if it just says find the missing term, you'd stop there. It'd just be answer would be 81. And this is kind of like a little side note for this part. So this is just an extension here. So we're saying that because this is what we're getting ready to do next, that if you can find this number, the whole purpose of finding this number is that the next thing we're going to do is that once we find out what this number is, we're going to factor it, and we're going to factor it so it's always something squared, which is what they really mean by completing the square. There needs to be something squared to make it work out. So, okay. All right, now here's what they're doing with this one. Here's kind of where they're going to get you this one. What they're going to ask you to do then is that if this kind of makes sense for what we're doing here, the next thing they ask you to do is, this is where they kind of do a combo of the two things. They may ask you to solve by square root property. Let's see if I can make it straight. There we go. But here's where they're going to kind of put the two things together so that you get this one. So we're going to do x squared minus 10x plus 25 equals 81. Okay, now here's what they're trying to get you to see. Again, if you're going to use a square root property, we've got to square root both sides. Square root 81 is fine, but if you look at this one, you go, how in the world are we going to square root that? All right, here's what we're going to do. Here's how you do that. What are the factors of 25 that equal negative 10? 5 and 5, right? Both of them is going to be negative. So this would be, if you think about factoring this, that'd be x minus 5, x minus 5. So technically this is x minus 5 squared. And of course, we just got the 81. So that if we can get it here, it's almost like what we were doing, there. But the difference is it's not just x squared now. Now it's x plus or minus something squared. And if you do that, if you square root this thing squared instead of just the answer being x, now the answer is x minus 5. And square root of 81 is still 9. But again, because it's x squared, we still need two answers, right? We need this to be positive and this to be a negative. All right, which means one time we're going to do x minus 5 and let it equal 9, or negative 9, doesn't matter which one we do here. And then one time we're going to do x minus 5 and let it equal positive 9. So then I go plus 5 and plus 5. So x would equal negative 4 on that side. But then solving this one, we're going to add 5 to both sides. So then x would equal 14. Okay, so basically what they're kind of getting you to see is that if you look at something and they ask you to solve it, if you look at this one, you go, oh, that's a perfect square root number, there's probably a shortcut that you can do to get that answer, to get through what you can do. So if this is a perfect square root number, this is 5 and 5. If you put that 5 and 5 together to get this number, then again, you can rewrite it twice. So it's like this, and then you can just square root both sides. And usually the math is not too bad if you do that. Now, somebody's saying, well, could we have just subtracted the 81 from both sides and then just solved by factoring? You could have. They're just throwing this out there as another option that you can do that maybe, if you're not a big factoring fan, because some people don't like factoring, then this is another option you can do if you don't like to do factoring. Do you have to do it this way? No, not necessarily. We're just trying to show you something out there that this possibly could work out to be something that you could do. It's just a different method that you want to go with there. All right, let's give you one more of those, and we got one other little thing we're going to show you, and then we'll be done for the day. All right, so this one, little twist on this one. We've got 4w squared plus 12w plus 9 equals 49. All right, and here's one that most people would look at this and go, I've got to bring the 49 over. I'm going to have to do the 8 times C. And then you're going to be like, well, I'm doing 4 times. If you subtracted 49 from both sides, this would be negative 40. If you did the AC method, you're doing 4 times negative 40 for negative 160. And then you're going to start breaking down negative 160. Yeah. And most people go, no, thank you. Right. All right. So here's the other option you can do. If, okay, this is a perfect square root number. That'd be 3 times 3, right? First number, also a perfect square root number. 2 times 2. Okay, so the check is, the shortcut is, could that be 2w plus 3 and 2w plus 3? Because we know 2 times 2 will get us 4. We know 3 times 3 is going to get us 9. It does the other stuff, if we're doing the full method, does the OI in the middle, if we do the OI method, does that come out to be 12? 3 times 2 is 6. 3 times 2 is 6. So we got 6 plus 6 to make it 12. So in that case, there's a shortcut because we got a perfect square root here, we got a perfect square root here, and that middle number winds up being, if we did 2 times 3 for 6 and 2 times 3 for 6, we add those together and we get 12. So in that case, we could just rewrite this thing as 2w plus 3 squared equals 49. And that way now it's a perfect square. We don't have to do the whole big AC method of doing 160 and going through all the factors of 160 till we find the pair that would come out to be 12. And now we can just take the square root of both sides. Because if we square root this thing squared, that's just going to knock out the square and leave you 2w plus 3. And if we square root 49, we're going to get a positive and negative 7. Okay, and then the hardest thing becomes, well, obviously, other than pairing it up so it looks that way. Now, one time you're going to do 2w. I cannot draw 2 for some reason. 2w plus 3 equals negative 7. And we're also going to do 2w plus 3 equals positive 7. Okay, you might get a whole number. You might get a fraction. Don't know until we work it out. Just have to see. Subtract 3 from both sides. And it's 2w equals negative 10. So this one comes out to be that w is just negative 5. This one will subtract 3. 2w equals 4. So w would equal 2. Okay, so the whole square root property, the completing the square, all the stuff, is basically saying, okay, if you get perfect square root numbers or perfect square numbers, if the first term is a perfect square and the last term is a perfect square, if it's ax squared plus bx plus c, if these two things are perfect squares, look for a shortcut. Now, this one may not have been a big, huge shortcut because the first term was x squared, but if the first term is not 1, if it's 4 or 9 or 16 or 25, then you probably got a shortcut you can look at, especially if the C term is a square number also. Okay, now here's the last thing. I'll show you this one. And this is one of those things that you do not, this is completely, totally optional. If you want to write it down, you can. If you don't, you don't have to. It's just one of those things we have to show it to you. Because you can solve this one a different way if you wanted to, and you don't have to necessarily do it like this. So you can either, I hate to say I give you permission to tune me out for a minute if you want to, but you can tune me out because I have to at least show it to you. And then, what we do with it after that, that's up to you. All right, so this is still just another one of those where it's solved by completing the square. All right, the big difference on this one is they're not perfect square root numbers. They're not perfect square numbers. Okay, so there is no kind of shortcut like we hit on the last one where we had perfect square numbers here, and we had a perfect square root number here, that all these numbers except for the B term were all perfect square numbers. This one, we don't have any of that. So if they were to ask you to do completing the square in this case, you would start off doing like we did before. You would just take the B term and divide it by 2 and then square it. So be like, what about the 2? Just ignore the 2 for a little bit. Just pretend it's not even there. All right, so that's -3 squared. So that's 9. Okay, and just like if we were completing the square before, we would put this 9 over here on the left-hand side. To do that. All right, now here's the catch, and here's what throws people off when they start doing this one.
Teachers, please pardon the interruption. At this time.
Okay, now because it's an equation, if it was just this statement that was here, we would add the 9, it wouldn't be any problem. But because it's an equation, if you add 9 to the left-hand side, you also have to add 9 to the right-hand side. So they get you this. So you got x squared minus 6x plus 9 equals 11. All right, now left-hand side, you do have this because the factors of 9 that equal -6 are -3 and -3. So that's x minus 3 squared equals 11. Okay, and now that it's x minus 3 squared equals 11, we can square root both sides. All right, and again, because you're squaring the squared number here, the square root and the squared number, those cancel out. That leaves you with x minus 3 equals plus or minus square root 11. Okay, now, and you would think you would never be happy that the answer was a square root, but in this case it is, because if you add this 3 to both sides, you actually have your answer. You don't have to do any simplifying because it's just 3 plus or minus square root of 11. Now, somebody may be asking, why would we ever do that? Because here's the other option. The other option is because of how this thing was set up back here, you would have to move this 2 over here to the left-hand side, and you'd have to do the quadratic formula. By doing it this way, you don't have to do the quadratic formula. So if you're one of those anti-quadratic formula people, this might actually be an easier option for you. If you don't mind doing the quadratic formula, then this way probably doesn't really do a whole lot for you. Now, and usually, I remember when I had to learn this, the thing that always threw me off was I could get this number and put the 9 here. I was always really, really, really bad about not putting this 9 over here on this right-hand side. I just always forgot to do that. But then it finally clicked with me one day, okay, this is an equation. If I add 9 here, I've got to add 9 over here as well. So I got to make it balance out on both sides. But some people, that throws them off a little bit because they're like, well, why am I adding the numbers on both sides? Why don't I just do something else? Well, technically, if you complete the square, that's what you're supposed to do.